Okay, well, here we are. This is week 10, I think. What I'd like to do today is finish up talking about patterns and chapter 5. So that is primarily going to be real-time interaction with patterns. And we'll also introduce a couple other things which are actually not in the book, but which I think are worth knowing. And then if we have time at the end of class, we'll start in on our next topic, which is chapter 6, and that's all about signal processing effects, signal flow, buses, and just how the server actually handles multiple synths that are interconnected. All right, so what I have for us today, I just basically pulled this synth-def straight out of companion code 3.4, which is like the basics of FM synthesis. So it's just a very simple FM synth-def. We have an envelope, which is maybe a little bit more detailed than we need, but it's basically an ADSR envelope where we peak at 1, we go down to a sustained level, and then back down to 0. The attack, decay, and release are parameterized. And this is like shorthand that I have been using to specify curvatures. So this is the curvature of the attack, curvature of the decay, curvature of the release. 3 is the release node, so that's where it will sustain as long as the gate is positive. Here's our modulator, and you can review, the relevant part of the book if you want to learn about kind of FM ratio and index and stuff like that. And that gets applied to the frequency of the carrier. We have an envelope, we pan, and out it goes. And it sounds like this, very basic FM sound. If you know anything about FM synthesis, you'll probably remember that as we increase the index of modulation, we make more and more sidebands, and so the spectrum gets richer and richer. We can all these sorts of funky, computery, electronic-y sounds. The ratio, this is the ratio of the frequencies of the carrier and modulators, so nice sort of integer ratios will preserve a sense of harmonicity, and then non-integer ratios tend to, spread the harmonics out in a sort of strange way. And, just to give us some synthesized source to be working with. So the first thing I want to talk about are a pair of patterns called Pmono and PmonoArtic. They are in the same general category as Pbind in that they are event patterns. So just to recap what we know about Pbind, what are we going to do here? Let's say legato 0.1 degree. We'll just do something kind of, we'll make a minor pentatonic scale here. And we got our pattern, and we'll play it on the default tempo clock. Just picking random scale degrees, and let's go ahead and make let's make legato 1. We'll set the release to be long, and now they kind of overlap. And this is the node tree. I've probably showed this before, but just in case we haven't actually talked about it, it's a representation of all of the active processes that are on the server. And as you can see, at any given point, it doesn't refresh very quickly. It's not sort of live. I think it only updates 4 to 5 times per second. But you can see at any given point in time, we have several instances of our FM synth-def manifesting as synths on the server. And that is because when you play a Pbind, you get an event stream player, and each event is a note event. So each time an event is generated from this event stream player, it's a new synth. New synth, new synth, new synth. And the initial parameters of each synth are determined by whatever patterns we've plugged into that Pbind. And this is useful, particularly for generating these large kind of clusters and textures, and lots of synths just as a way to algorithmically spew them onto the server and get these kind of interesting, rich sounds. That would be really challenging to do if we were just doing synth, 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 synth ourselves. But sometimes you want to create a pbind which kind of plays a melody or something like that. And it's true that you can do that with pbind, but you just have to keep in mind that every single component of that melody is its own synth. And if you have like a really processor-intensive synth and the notes are all kind of overlapping, you're actually generating a lot of synths, and it can get kind of computationally expensive. And it can be, on the same sort of thought, it can be kind of annoying to deal with pbind when generating melodies, because you then have to kind of micromanage the envelope parameters and have each note kind of end at the right time with the right kind of release before each note starts. And it just gets a little, messy. So Pmono is useful because what Pmono does, the syntax is nearly the same as pbind, but when you play a Pmono, one synth is generated from the very first event. So the first event is a note event, but all of the subsequent events are what are called set events, and those generate set messages to that synth. So the mono, if you haven't figured out already, is short for monophonic. One synth, and all of the events are set messages, and so you can you just automate these set calls, and whenever the event stream generated by that Pmono is finished, it will then send the corresponding gate 0 message and fade out that synth, assuming it has a gate argument. So let's just look at an example. In fact, I'm just going to paste this. And we're going to say Pmono. The main difference between Pmono and pbind is that there's no need to actually say instrument. I think this is the syntax. We just tell it, this is the synth def to use, and here are your parameters. So we'll just go ahead and make this, and we'll say q equals p.play. What have I done? I wonder if... Now, why did that not work? I'm going to figure this out. See if we do this. Let me grab my notes. Maybe this needs to... If I get rid of this. I am missing something glaringly obvious. Well, let me just look at the examples in the help file here. Oh, you know what the problem is? I think I figured it out. No, I didn't figure it out. That one's fine. What's wrong with mine?
Is it the last comma at the end?
I don't think so.
Oh. Yeah.
But good, yeah, that's worth a try. Well, we're just going to sort of look at these side by side and figure it out here.
If we just invoke play on the original Pmono?
That would be the thing to try. I don't see any difference other than that. Maybe there's something wrong with my synth def. Sure, we'll just play this.
Oh, okay.
What if we go back to default? Okay, so there is something wrong with my synth def. What have I done?
Oh, freak is IR?
You solved it. That is it. Yeah, this is what I get for messing around with my synth def instead of just copying it as is. Right. If you want to send set messages to your parameters, you cannot run them at the audio rate. So let's thank you again, Maxwell. Let's do a find and replace here. And we're just going to go boop, 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 boop. And there we go. All right. Apologies. This should now work. And do I have to run it? Probably. Okay. Okay. All right. Sorry about that. So there's nothing wrong with just playing the Pmono as is or doing this kind of business. Right. And you can see on the node tree, we just have the one synth. Just the one synth, and it's receiving set messages once every quarter of a beat. We're using the default tempo clock, and we can stop that whenever we like. And then the gate message is sent whenever we... Let's do just 8 of these and play it. 3, 4, 5, 6. There's the last one, and then comes the gate message, and down it goes. So this is kind of nice. I mean, we can do something else here and say MIDI note. Let's do something low, like 32, and we don't need scale anymore. And we'll mess around with index somewhere between 0.5 and 10, and ratio. We'll say px brand 110, but we're going to round that to the nearest integer. Make it a little faster, and maybe this will sound cool. Yeah, we might want some amplitude information here. Maybe make this a little bit louder. So that'll just kind of run. Throw some random durations at it. Maybe that's not an octave. What is it? 44, 56. Yeah. All right, and so if we try to shorten the legato time, just have them be little staccato notes, this doesn't work. Even when we get a long duration, it's basically ignoring legato, because it's a single synth, and we just don't have a mechanism in place to actually kind of cut off the note and bring it back. And this is where PmonoArtic comes into play. So it's a variant. I think technically it's a subclass of Pmono. And this one will check the legato time. And basically the idea is that if the resulting sustain time is shorter than the event time, it will send a gate 0 message to actually fade out that synth, and then at the next event it will create a new synth and start sending set messages to that one. So if necessary, if there's a legato time which says this is a shorter articulation, it'll wipe that one away and create a new one. So we'll shorten the release as well, just to really accentuate the shortness of these notes. So now it's kind of behaving like Pbind, where all of the legato and release times are shorter than the duration. But then we can set the legato time to be kind of random. And so some of these will actually sustain into the next note, and the synth will remain in existence and continue to receive set messages. But then eventually we'll run into a short legato time, and we'll create a new synth as necessary, I think. Let's see if this works. I think we should do P white here and maybe make this. Well, I'm going to tweak my parameters a little bit more. Let's make the sustain level really low, so you'll really be able to hear the articulation. And well, let's just upscale all of these by 2. So some of the note changes, there's no re-articulation because it's the same synth just receiving set messages. But when the parameters are such that the synth ends before the next event, it'll fade it out and restart it. So yes, you have a question.
Is this smart in the sense that, like, if your done action was 0, would it just send a new gate on articulation to the synth?
Can you ask that again?
In the synth def, if you have done action 0,
Right.
Instead of 2, would it then sort of just go, oh, like it would then just retain the same synth, and instead of making a new synth, it would just send a gate 1?
No, I don't know. So if done action were 0, I don't think the PmonoArtic or the resulting event stream player knows anything about the default value of any arguments in the synth. All it knows is the values that are being passed to it, so I'm not exactly sure what would happen if done action were 0. My guess is that everything would continue to behave normally, but at the end of a finite event stream, the synth would not disappear.
Okay.
Let's see if that's actually what happens here. So we'll wrap all of this in a pfin doer, and we'll say 10 seconds. Oh, no, so whenever it rearticulates, we get a ghost synth, not just at the end.
Interesting. Good to
Yeah,
know.
right. So yeah, done action 2 is definitely the right choice here, because it might have, the event stream player is going to have an end, and it might have to rearticulate, and you don't want those ghost synths just hanging around. All right, that's pretty much all there is to Pmono and PmonoArtic. I've just seen a lot of examples over past years where pbind is the only thing that I've taught students, and then there are situations where Pmono really makes a lot of sense, but it's sort of this extra work being done to mold the pbind into behaving that way, and Pmono is sometimes just a much simpler sort of thing to do. Okay, now on to the real-time pattern control topic. So when we create a synth, we've seen that we can then dynamically send set messages, or build those into a routine and play the routine to automate the production of set messages. And we can just sort of, if we parameterized our synth correctly, we can just change it and modify its sound as it's running. And a very natural question is, okay, can we do this with patterns? So if we we just play this Pmono like this, and then I want to offset the MIDI note by 3, so transpose it up a minor third. Well, this doesn't work at all, right? All we've done is create a second Pmono, play it, and it's just kind of happening at the same time. We didn't bother to quantize them, and so we lose the reference to the first event stream player by calling this one P as well. And so you might think, okay, what about like p.set? Let's set MIDI note to be, well, I'll just tell you right now, this doesn't work either. We can't send set messages to a pattern. What we need to do is a little bit of planning ahead. So the first pattern I'd like to introduce is called Pdefn, and this is one of several objects that are in the category of what are called proxies. And proxies are a concept which are mostly kind of centered around SuperCollider's live coding tools. And a proxy is just really a wrapper that keeps a reference to some data and allows us to dynamically change that data, even in a sort of context where that wouldn't normally be possible. Pdefn is a pattern which we use when we want to give real-time control to a single value pattern. For example, MIDI note. If we wanted to dynamically change MIDI note, this can be what we would do here is when we define the Pmono, we wrap the data in question in a Pdefn, and one of these proxy def style objects. Synth def is kind of exactly the same. You need a symbol to give it a name, and then the content in relevance, the stuff we actually care about. So I'm just going to call this fm_MIDI note, and then close that. Oops, no, yeah, it's already closed. All right, so and we'll reinitialize this just to what we originally had. So, and then we'll also keep this kind of separate here. So q equals p.play. I won't play this just yet, but I'm going to prepare an expression which will update the Pdefn. And all we really have to do is call the Pdefn again and optionally provide it with something new, like this. So here we go. We have our Pmono. Our MIDI note information is pre-wrapped in a Pdefn. And then we can just run this line here. We can do this sort of thing. And by making this value pattern finite, we've we've made the enclosing event stream player finite. And so the question now, I'm not actually sure, is this still running? No, it's not still running. I thought maybe this would wake it up again, but this is the basic concept of Pdefn. One of the uses of Pdefn that I think is particularly handy is as a way to fade out a pattern. So one thing you can do when you are, and I'm going to switch over to pbind just to show you that this Pdefn business applies to any kind of event stream player. So this will be pbind instrument. Man, I can't believe I forgot to make my arguments control rate. Here I am sitting here. All right. So this is the same sort of thing here. And let's just see what it sounds like. Yeah, so now overlapping new synth for every event. Turn this down a little bit. Yeah, okay. And I'm going to say I'm going to use Pdefn to fade this pattern out, which is something that we normally can't really do unless we give ourselves the option to do so. So I'm going to say Pdefn fmdb. And we're going to initialize that to -20. And we'll prepare a little line for ourselves here. And so now we can sit here and kind of do this manually and do this. If you want to kind of do a live coding thing here. And once it's quiet enough, you can just, I don't know, command period on that, or make this into a finite pattern instead of a single value. But there's a way to automate this as well by just replacing -20 with this as pseg trick that I showed you all last time. So we'll start at -20, go down to -80 over 15 seconds as pseg. And off it goes. Yeah. So we've just swapped in a pseg, which is the pattern version of this envelope that goes from -20 to -80 over 15 seconds. The pseg that is produced as a result of this application of as pseg is a finite pseg. So once it gets to the end, the enclosing pbind also stops. So handy if you can remember to sort of, if you play this pbind without giving yourself a Pdefn, you cannot really add it in later. It kind of has to be a Pdefn at the beginning. And then the other thing to keep in mind is that when you change the value of a Pdefn, that change will propagate to all instances of that specific Pdefn. So this is a way that you can have multiple patterns running, and you want to take some core pitch information inside of a Pdefn, but then you can also add things and multiply things by that Pdefn all throughout your pattern space. And then when you change that Pdefn, you'll hear that change everywhere that Pdefn is deployed. I'll try to do a quick example of that. So we'll keep our FMDB thing here, and we'll say FM MIDI note is going to be 35. And we'll just play this and play this. Need this, and we'll just do something kind of simple here, and just add 12. So this Pdefn is just basically a wrapper. It doesn't change the data at all. It's just allows us to reference it while it's running from some external source. So these will be an octave apart, but the let's make it 24 just to make it extra audible here. So we'll do this, and I've forgotten a parenthesis somewhere. I think, yeah, I just had an extra one there. Nope, and an extra one here. Yeah. Okay. So the index and ratio are all kind of random, but the fundamental pitch stays the same. Right. Let's see. Random in both cases. Both of them get a prand, I think. Right, and then let's go ahead and do this again. They both got the same FMDB, so that applies to both of them. I actually wasn't sure if this was going to be the exact same randomness for both, but I guess it's not. So, oh, and what's going on here? Too many nodes. Did I forget to? I think I forgot to change this back. No, it's still done action 2. What's going on? I'm going to have to watch this back afterwards to see where I messed this up. Play this again. Right? And I was messing around with this. There's nothing wrong with this. So, must have been something from earlier. Because, all right, well, irresponsible coding. You've seen it here first. Okay, so that's Pdefn. Good for single value patterns, which can then be kind of put all over the place. And anywhere that symbol appears, it'll respond to changes. But it's not always the best choice. For example, if you have a pbind and you're playing it and you're imagining lots of changes to lots of different parameters, it's pretty annoying to have to do a Pdefn for every single one of those value streams. Because then you have to like name each one uniquely, and that's no good. So Pdef and Pbindef are versions of the same thing, where the pbind itself is the proxy content rather than an individual data stream within that pbind. So that would look, and another benefit of Pdef is that you no longer need to rely on variables because the Pdef is going to have its own symbolic name. So what that would look like here is we have Pdef, we'll call this P, and its content is a pbind. Okay, and so we don't even really need these Pdefns anymore. We're just gonna put the data straight in there, and we'll just play it as is. And this is a nice approach because there's really no difference between the code that initializes the sound and the code that you would use to modify it. So we'll just play this, and then you can just start changing stuff. We're sort of fully in like live coding territory here. A little quieter. Longer release. Longer sustain time, I think. And then we can do the same kind of thing here. And minus 20 minus 80 over 10 seconds as pseg. All right, pretty good, right? This is useful stuff if you want to sort of take a stab at kind of performing with patterns and not just kind of writing them in advance and then queuing them up in a sort of non-real-time sense. So this is, yeah, go ahead.
Does the Pdef allow us to like add a named key in the pbind that wasn't there earlier?
Oh, yeah, great question. So yes, it does. It is possible to, first of all, let's wipe its memory here. You can just tell it to forget everything it ever knew about itself by just clearing it. And so your question is, can we dynamically add keys? Yeah. We can. There's one little snag, which is that if you add a key, change some values, and then remove it, it remembers, right? Even if it's not actually there, it's still sort of, you haven't overridden that key. So let's just see if it is. I mean, you can kind of undo that, but it can get a little messy. I think that probably the way to do it is to like give yourself all the parameters in advance. But let's just kind of do it step by step. I'll build a new one, you know. So I wonder what happens if we just do this. There's back to we cleared it, so it remembers this stuff. But then we'll say let's do from -7. No, negative. What am I doing? -7 to 7. Let's do I'll just make them all a pair of synths. A little beating going on. And hey, it's kind of nice. So then if I kind of like delete this stuff, you know, nothing changes. It remembers. It's not there. Oh, wait a minute. No, it does. Oh, I'm wrong. There was a, okay. So if I take this away, it's going to go back to, yeah, I think that's interesting. But here's something that I think will mess it up. If we comment this out and say, let's do MIDI note p white 50 to 70. Okay, so that change happened. And then if we go back, all right. Well, I know when I was writing this book, I ran into a situation where you know, there are problems that can arise from it remembering stuff. So either I'm wrong, or I'm just not conjuring up those specific situations here. But I don't know. I guess the answer is just, you know, explore, see what happens. Yeah. Anyway, yeah, pretty fluid experience, right? You just sort of have it spontaneously. I don't know, change the pitch, change the amplitude, change this, change that, and yeah, where's my as pseg? Come here, you. Let's put you over here. going to review this chapter, make sure I didn't screw something up in this book. Well, anyway, but you get the idea with Pdef, yeah, very handy. Pbindef is almost exactly the same thing. And there's probably some situations where it doesn't really matter which one you use. So let's, I mean, in fact, they even share a namespace. So if I say pbindef, p.play, it's kind of exactly the same thing almost. Right? Maybe the remembering problem is a pbindef problem. I think that's what I'm getting at. Yeah, see, it remembers this business here. That's why it stopped, because yeah, we ran this, and this was the last value pattern that was provided for DB. So it remembered that, started at 20, went down to 80. But we can wipe its memory, and we'll take this, and we'll actually just put this here for a little clarity here. So pbindef is it's, if you can't tell, it's a portmanteau of pbind and pdef, and the syntax is almost the same. That we don't actually need the pbind enclosure. It's sort of a 2-in-1 deal. Yeah, so we give it the name of the proxy, and then just the key value pairs that would normally appear in a pbind. And so let's return this to -20 and play it. And now this, let's see if I can, let's see if I've really lost my mind, or if I'm correct about this remembering business. All right, so now we're going to, my assertion is that this pbindef will remember degree. I forget which one's going to override which one I was going to, but okay, so now we're in MIDI note land. If we go back here, yeah, and this is well, I do not know why this happens with pbindef and not pdef. So good reason to use pdef, I suppose. But it is related to the hierarchy of pitch information and sort of the upflow, where it starts at degree, which has a default value of 0. Note is calculated from degree. MIDI note is calculated from note, and so on. And so we gave it degree information, but then sort of cut the chain short by giving it MIDI note information. And so even though we went back to degree, the note is calculated, but then MIDI note's calculation function has been overwritten. It's now just using these raw values. And so it's basically ignoring degree. So what we have to do here is say, I think nil for degree. Let's see if this works. Or no, sorry, I have it backwards. We want to keep that where it is and set MIDI note to be nil. Now we're back in diatonic land. Yeah, and this is kind of messy, but I guess maybe the real solution here is try not to mix and match pitch information. Like if you're thinking in terms of degrees, try to just continue thinking in terms of degrees, and don't jump around, because it's just one of those little sort of back-end quirks. You can also stop them just like you stop a pbind. Well, actually, no. You don't stop a pbind. You stop the event stream player, and so you have to, when you play a pbind, right? You've got to refer to the process that is returned from playing it. That's the thing that can be stopped. Right. So if we, I'll just do this real quick. So if we do this, and then this. Right, this doesn't do anything. Right, that's not the process that's playing. It's Q, the event stream player, that needs to be stopped. But with Pbindef, we can play it and stop it, and there's no need. I really like it because there's no need for any variables that you need to worry about stepping on each other's feet or anything like that. So I'll stop there and sort of take questions if anyone's got any. Anything along the lines of what would happen if you did X, Y, Z, or would this work, would that work, or would this break it? The reason I wanted to talk about Pbindef is, so with Pdef, you must, every time you reevaluate a Pdef to give it new parameters, you have to give it the entire thing. You can't sort of selectively say only change this or only change that. With Pbindef, you can. And so that, we'll go ahead and play this. And let's just clear it. Did I stop it? Is that why? Let's just say pbind p clear. And is there, okay, let's get rid of that. That's probably the problem. Yeah. All right, so this is playing. And if I wanted to bring these up 2 octaves, I could do this. And then that would work. But you also can just do this. Take this, just do a single key. So sort of one at a time thing, just in case this is like off screen somewhere or in a different file and you know what it's named and you don't have immediate access to the whole thing, but you know what you want to change. So you can, and you can chain multiple key value pairs together. So this will take it down a little bit. We can say attack 0.1, release 0.3, or yeah. So it's a little bit more fluid, I guess, if you just want to kind of spontaneously specify patterns. But this works too, if you just want to be dealing with the whole apparatus and changing things incrementally here. Ultimately, there's very little difference, I think, between one and the other. But you can't do this with Pdef, but like you can just kind of change these individually with Pbindef. And then the last thing I think I wanted to talk about was quantizing, because that's it's a little bit, the syntax is a little bit different with Pdef and Pbindef and Pdefn. So with patterns, just grab this. We have already seen. Quantizing here. That we'll just use the default tempo clock. We just say play on default and quant 4. Right? So we make our pattern, and then it'll wait for the nearest beat multiple of 4, and then start playing. Right? So we can say. Same thing, and these will line up with each other. I guess you can't really hear it because they're kind of very similar. But you can hear there's R playing, and we've seen this already. For Pbindef, we'll do this, and we'll call this one P. I'm gonna clear that real quick. And the way we do it here is we don't stick the quant information in the play parentheses, but we apply it as an attribute to the Pbindef itself. So it looks like this, .quant underscore, and then in parentheses, either an instance of quant or an array of quant values or just a single quant value if we only care about granularity. And so we just chain these together. So as we create Pbindef P, we give it its key value pair information, we give it a quant value. You would also do clock, tempo clock.default, or if you've made your own clock, you plug it in here. So this is the syntax here. You say .method underscore to set the value for that attribute. It's already using the default tempo clock, but you get the idea. So we'll make this and let this play for, you know what, it's not going to make much sense if we have these random dur values. So let's go back to something a little bit more rhythmic. And we'll do over 8, so you know, an eighth of a beat. And there we go. And let's make this a little bit more interesting. And then I'd like another one. Call this one Q. And we'll just make this 45. And so just slightly different syntax, but these proxy style patterns can totally receive clock and quantization information. It's just a little bit of a different syntax. Yes?
So am I hearing correctly that the quant is also applying to parameter changes and not just the starting of the thing? Because it seemed like there was a delay between putting new values in.
The delay is because I've selected 4 as the granularity for the quant. So when I, you know, run the code for this Pbindef, it won't necessarily happen immediately, but you know, when we initially played the Pbindef, it was looking at the tempo clock and saying, waiting for the next, and there's the multiple of 4, and off we go. And every time we reevaluate this Pbindef with, you know, new or identical information, that change will again happen on the next beat multiple of 4 on the default tempo clock, because that's the information we've applied to it. And I just like to leave this information here. There's no harm in playing a Pbindef if it's already playing. There's no harm in re-providing the clock and the quant stuff. So this kind of code structure I think works really well, because you can just kind of focus on your parameters, change it, run it, change it, run it, change it, run it, and you're pretty much good to go.
So if we had like played that with the quant, but then we like sort of had a copy of that without quant and clock that we were changing values, would those changes be immediate, or because it had been instantiated with the quant, that quant would be persistent?
Good question. So if we ran this once and then copied it, removed the clock and quant information, no, because once we apply these methods to the Pbindef, it remembers. It's like setting a synth. It's like, you know, if you or maybe that's not the greatest example, but I'll just sort of show you. So we'll copy this and paste it down here. And so if we run this, then what I'll do is I'll change this to another number, but remove these and run it. And I think it'll remember the clock and quant information. Okay, so off it goes. And then if we take this away, I was a little bit off, but yep, it still would if you would remove the play. Yeah, it doesn't change the fact that it's already playing. Right? I guess you'd have to say like .stop here. That would work. Right? You can play it again. Right? Waiting for the next beat multiple of 4. So it remembers all this stuff. F. Clear. Yeah. Yeah. So stop will just stop it, but it remembers its quant, remembers its clock. It's just no longer playing, and it remembers all the information in here, and then you can just resume it. So it's you know, once you get a sort of a basic grip on the syntax and you're comfortable with your parameters and your synth stuff, it can be a really kind of fun experience. And what I'm leaning towards for the next homework assignment is I think I'd like to kind of switch gears and do something which is less like answer these questions and more like do a 1-minute real-time pattern composition. I'll set some basic parameters, but I'll try to be really flexible with the deliverables here. So you could do a screen recording if you wanted to. You could just make a recording, and I'll just show you how to do that real quick. With you can say s.make GUI with a capital G. You get this little thing here, and then you record, and you will play your pattern, right? And off it goes. You make some changes. ends your performance, and then you hit stop, and then you can go track down your recording, which it'll tell you where it goes. Or you could just write it in sort of a code style and write out all of your live manipulations as things that I can run on my own. Anyway, and I'll give you 2 weeks to do this, because I know this is kind of a new thing for a homework assignment. But I think it's kind of, after a while, these problem set style assignments, are only so valuable before I just need to sort of push you all into the deep end of the pool. You know what I mean? So, but I hope you have some fun with it. I'll jot that up and put it on the assignments page sometime later today. And we will move on and talk about signal processing, effects, signal flow next week. All right. I'll see you all then.